Guys, we're going to do a follow-up lesson here today about the true-false cases when you're doing the elimination method. We looked at these when we did the substitution method, and the results come out the same, but it just looks a little bit different when you get there. Remember, with the elimination method, our first step is to make sure that everything is lined up. So we have our x terms lined up, the y terms lined equal sign, and the constant on the other side. And the next thing is that you want to add your equations together to make something cancel. But 3 plus 2 is 5. That doesn't cancel. And negative 3 and negative 2 doesn't cancel. So we're going to have to multiply here to get a common multiple so that we can make it cancel. All right, so the top equation, I'm going to try to turn these into sixes. If one of them is a 6 and the other is a negative 6, we'll be good to go. So if we multiply the top, everything by a 2, we would have 6x minus 6y equals negative 30. Okay, the bottom equation, I'm going to multiply everything by a negative 3. Okay, so this would be a negative 6x, which is exactly what we wanted, so that the x's cancel. And then we'd have a plus 6y, and then a positive 30. Now we're ready to add them together. When we do that, the x's cancel, so we get a 0 there. But the y's also cancel. And these also cancel. So we end up with our variable gone, both of them, x and y, and we have a statement that says 0 equals 0. Well, 0 does equal 0. That is true. So that means this is a case where no matter what, you have a true solution. So this means the lines, if we graph these lines, they would be right in the same place. Okay, so they would graph on top of each other. That means that they share every point together. So there's infinite solutions. That is called consistent dependent. Okay, because they're actually the same line. So we started the problem just like normal, and then everything canceled, and we ended up with something true. You know where I'm headed now. Let's take a look at these two. It appears that the 6x and the negative 6x would cancel. However, if you notice, these are on the same side, and those are split. So you have to get them lined up first. What I'm going to do is just add 5y to both sides on the bottom equation. So we have 6x minus 5y equals 18. And then on the bottom, we have negative 6x plus 5y equals 13. Okay? So we added 5y to both sides so that everything would be lined up. Well, we're ready to add these together because these coefficients cancel, so the x's are going to be gone, and I should get something for y, but the y's also cancel, so I'm down to a 0 on that side. But over here, we have a 31. Now that is not true. 0 does not equal 31. So in this case, we would say this is false. And that would mean that since our variables canceled and it left us with something false, no matter what, we're never going to make it work. So there are no solutions, which is called inconsistent because there's no solutions. And that's because these lines are parallel. If we graph them, they would never share a solution. Okay? The ones we have been doing would be a case where you add them together and you're solving and you get something like maybe x equals 0. This does not mean that things cancel. This means that x equals 0 and that you would take that 0 and plug it back in to find the y value. okay? That would be our regular case where we get one solution because the lines just crossed once. So that is consistent, independent. Okay, so the same labels that we had before, it just comes out a little bit different. It's either going to be 0 equals 0, or you have 0 equals something that doesn't work. Okay, so this would be one solution here. And finish it off because the lines cross once. Okay,